Good day, everyone, especially to our instructor, Mr. Don Francis Cabreras Prado, sir. My name is Gracial C. Esperanza, and I'm from BSIT 2C. What is memory management? So, it is the process of controlling or coordinating computer memory. Parts called blocks are allocated to various running programs to optimize overall system performance. So memory management resides in hardware, operating system, and program and application. So how does it work? So main memory refers to physical memory, which is the internal memory of the computer. The main memory is called RAM. The computer can only change the data in the main memory, so therefore, every program you execute and every file you access must be copied from the storage device to the main memory. So all programs are loaded into main memory for execution. Sometimes a complete log program is loaded into memory, but sometimes a part of a program or routine is only loaded into the main memory when it's called by a program. So the mechanism is called dynamic loading, which can improve performance. So the need to use memory management. So now let's see the need to use memory management in operating system. The details are follows. So first, you need to place the program in memory to make full use of memory. Second, you should also make sure that this application do not interfere with each other. Third one, it allocates space for application routines. Fourth, it helps protect different processes between each other. Fifth, it tracks when inventory is released or unlocated. And lastly, it allows you to check how much memory needs to be allocated to the process to decide which processor should acquire memory. So, memory management techniques. So, here are some of the most critical memory management techniques. So, segmented memory management. So segmented memory is the only memory management method that not provide linear and continuous address space for your programs. Segments require hardware support in the form of segment tables. It includes the physical address, size, and the data and other data of the section in memory, such as status and access protection bits. So second, the single continuous allocation. So continuous memory allocation in OS is the simplest memory management technique. In this method, except for a small parts reserved for the operating system, all types of computer memory can be used for an application. For example, the MS-DOS operating system allocate memory in this way. So, partitioned allocation. So, it divides the main memory into various memory partition, most of which are continuous areas of memory. Each partition store all information for a specific task or job. Its working methods include allocating in partition when the jobs start and canceling the allocation when the jobs end. So, page memory management. This method divides the computer main memory into fixed size unit called page frame. The hardware memory management unit maps page into frames that should be allocated according to pages. So memory allocation. So memory allocation is a process of allocating or memory or space for a computer programs. It has been three types. So first fit. The first hole large enough is assigned to the program. Best fit. The smallest enough hole is assigned to the program. Worst fit. Largest enough holes to be assigned to the program. So, here, the swapping. Swapping is the process of putting each process in the main memory, running it for a while, and then putting it back to the disk. The process needs to be in memory to execute, but sometimes the main memory is insufficient to accommodate all currently active processes in the time-sharing system. Therefore, redundant process will remain on the disk and make it classify memory requirements for a computer system. Memory management keeps track of the status of each memory location, whether it's allocated or free. It allocates the memory dynamically to the programs at their request and frees it reuse when it's no longer needed. Memory management to satisfy some requirements that we should keep in mind. And these are requirements of memory management are relocation, protection, sharing, logical organization, and physical organization. So, relocation. The available memory is generally shared among a number of processes in a multi-programming system. So, it's not possible to know in advance which other programs will be resident in main memory at the time of execution of his program. Swapping the active processes in and out of the main memory enable the operating system to have a larger pool of ready-to-execute process. When a program gets swapped out to a disk memory, then it's not always possible that when it is swapped back into main memory, then it occupies the previous memory location. Since the location may still be occupied by another process, we may need to relocate the process to a different area of memory. Thus, it's a possibility that program may be moved in the main memory due to swapping. The figure depicts a process image. The process image is occupying a continuous region of main memory. The operating system will need to know many things including the location of process control information, the execution stack, and the code entry. Within program, there are memory references in various instructions and these are called logical addresses. After loading of the program into main memory, the processor and the operating system must be able to translate logical addresses into physical addresses. Branch instruction contain the address of the next instruction to be executed. Data references instruction contain the addresses byte word of the data reference. So next requirements is protection. There is always a danger when we have multiple programs at the same time as the program may write to the address space of another program. So every process must be protected against unwanted interference when other process tries to write in a process whether accidental or incidental. Between relocation and protection requirement, a trade-off occurs as the satisfaction relocation requirement increase the difficulty of satisfying this protection requirement. Prediction of the location of a program in main memory is not possible. That's why it is impossible to check the absolute address at the compile time assure protection. Most of the programming language allows the dynamic calculation of address at the runtime. The memory protection requirement must be satisfied by the processor rather than the operating system. Because the operating system can hardly control a process when it occupies the processor, that it's possible to check the validity of memory references. The third requirement is sharing. A protection mechanism must have to allow several processes to access the same portion of main memory, allowing each process access to the same copy of the program rather than have their own separate copy has an advantage. For example, multiple processes may use the same system file and it is natural to load one copy of the file in main memory and let it share by those processes. It is a task of memory management to allow controlled access to the shared areas of memory without compromising the protection. Mechanisms are used to support relocation supported and sharing capabilities. So move on to the part 1, logical organization. Main memory organization as a linear it can be one-dimensional address space which consists of a sequence of bytes or words. Most of the programs can be organized into modules. Some of those are unmodifiable, read-only, execute-only, and some of those contain data that can be modified. To effectively deal with a user program, the operating system and computer hardware must support a basic module to provide the required protection and sharing. It has the following advantages. So the first advantage is modules are written and compiled independently, and all the references from one module to another module are resolved by the system at the runtime. Second one, different modules are provided with different degrees of protection. And lastly, there are mechanisms by which modules can be shared among processes. Sharing can be provided on a module level that lets the user specify the sharing that is desired. So last requirement is physical organization. The structure of computer memory has two levels referred to as main memory and secondary memory. Main memory is relatively very fast and costly as compared to the secondary memory. Main memory is volatile. The secondary memory is provided for storage of data on a long-term basis, while the main memory holds currently used program. The major system concern between main memory and secondary memory is the flow of information, and it is impractical for programmers to understand this for two reasons. First reason, the programmer may engage in a practical known as overlaying when the main memory available for a program and its data may be insufficient. It allows different modules to be assigned to the same region of memory. One disadvantage is that it is the time consuming for the programmer. Second one reason is a multi-program environment. The programmer does not know how much space will be available at the time of coding and where that space will be located inside the memory. So move on to the role of memory in computer system and memory system. Memory management is the functionality of an operating system which handle or manage primary memory and move processes back and forth between main memory and disk during execution. Memory management keep track of each and every memory location regardless of either it is allocated to some processes or it is free. It checks how much memory is to be allocated to processes. It decides which process will get memory of what time. It tracks whatever some memory gets freed or unallocated, and correspondingly it updates the status.